Hi everyone, my name is Bhartich and in this video we will be discussing about limit points of sequence. If we say that xi is the limit of Sn, then the neighborhood of xi will contain infinite terms of Sn. If I make you understand diagrammatically, suppose as you know that xi is a real number, so it must be lying on a real number line. So then if somewhere here the xi lies, the neighborhood will be what? The neighborhood is a close radar to xi. So in this case, what we will be taking, we'll be taking a variable epsilon which is greater than 0 such that xi plus epsilon and xi minus epsilon creates the neighborhood around your limit point xi. Now in this interval, if Sn has an infinite terms, then only we will say that xi is the limit point of the sequence. Indirectly, what we are trying to say that whatever the values, if there are infinite values of Sn which is lying in this open interval, then what we can say that Sn minus this limit xi will be always less than epsilon. This is the criteria for being xi to be the limit of the sequence. So when we say that xi is the limit point of a sequence, when it is given that there exists an epsilon greater than 0 such that in the open interval this is also the symbol of open interval, or you can use this symbol, both of them represent open interval. In the open interval of xi minus epsilon, xi plus epsilon, there exists or there remains infinite terms of Sn, then only we say that xi is the limit point of the sequence. Now, in different books, you will be seeing that limit point has a different name. Somewhere you will see that this is also called cluster point. Limit point is also called as cluster point. Or it is also said to be as point of condensation. So we have these synonym of limit point of a sequence, that is cluster point and point of condensation. So it is clear that in this open interval, the set is of the range of Sn, because whatever the values we are giving to n, they are reaching towards this xi, and this neighborhood contains the range of Sn. So from here, one idea can be introduced that the limit of a range set of a sequence is also the limit point of the sequence. This is the important note that we have deduced with the limit point sequence definition. Let us take some few examples. For example, I have taken a sequence which is constant. Here you can see that the sequence has only one limit point and the range is 1. But the range has no limit. The range has no limit. But the sequence has one limit, which is your 1. The second example is the sequence Sn is equal to 1 by n. You can see here that the 0 is the limit of sequence Sn, because when n tends to infinity, you'll be seeing that the Sn value 1 by infinity is equal to 0. And if you write down the range of this set, the range of the set will something look like this: 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, 1 by 6, and slowly or gradually it is tending towards 0. So the limit point of range is 0. The next example is Sn is equal to 1 plus minus 1 to the power n. So here you will be seeing that the sequence has two limits, that is 0, because if you put for even, suppose infinity आपका even number हो गया, if it will be even number, it means that minus 1 to the power even number, the value will be equal to 2. If it will be odd number, it will be 0. So sequence has two limit, that is 2 and 0. And the range, if you see carefully, the range is 0 comma 2, because look at the definition of range which we discussed in the first video. It says that irrespective of the position or irrespective of the repetition, whatever the unique value comes, that gives you the range. And here we get the range as 0 comma 2. 0 comma 2 has a no limit point, so this range has no limit. In this way, you can see a various example. I would like to give you some homework so that you can try by yourself. So these are the two sequences. You have to find out that what will be the limit of the sequence, both of the sequence, and what will be the limit of the range of its sequence. Next, we'll talk about the Bolzano Weierstrass theorem, which states that every bounded sequence has a limit point. So according to this, if a sequence that we have considered is bounded, then it will have a limit point. Now, just think that if a sequence is bounded, whatever the range that we will be getting of a bounded sequence will be also bounded. That's why what you can say that there will exist a limit point L such that if you take out the neighborhood of that, infinite terms of the sequence will be lying inside that open interval. And this is true for any kind of the sequence that you consider, whether the sequence is finite, whether it is infinite. Bolzano Weierstrass theorem works if the sequence is bounded. Now what does it say? Let's recall every bounded sequence has a limit point. But let's ask a question whether the converse of this theorem is true. If a sequence has a limit point, whether it is a bounded sequence. So answer to this question is no. The converse of Bolzano Weierstrass theorem is not true. Let us take an example. If we consider a sequence Sn such that 1, 2, 1, 4, 1, 6, and it continues like this. Now look here, it has a unique limit point 1, but it is not bounded above. Now what does bounded sequence said? It should be bounded below, it should be bounded above. Though this is bounded below, but this is not bounded above. Though it has a unique limit point, but it is not a bounded sequence. So the converse of Bolzano-Weierstrass theorem is not true. I hope I have made these 2 points clear. In our next video, we'll definitely be talking about other theorems related to the limit points as well as the convergent sequence. Thank you so much. Take care and please do not forget to like, share and subscribe to my channel. Thank you so much.